In this video, I'm going to go through the 5 different examples that we have using the new trapezoid formula and how we can use those formulas to help us solve these area-related problems. So this first example is pretty straightforward. It asks us to find the area of the trapezoid and it gives us all the information that we need. So to find the area of the trapezoid, I'm going to use that formula from the first video, which is the height times base 1 plus base 2 divided by 2, or that's the same thing as 1/2 h times b1 plus b2. And I'm just going to substitute all of the numbers that I have. So the height of my trapezoid is 7, base 1 is 12, base 2 is 18, and then I'm going to divide that by 2. And so if I continue to simplify that, I get 7 times 30, divide that by 2, 210 divided by 2. So the area of this trapezoid would be 105 units squared. So very easy, very straightforward example of how to apply the area of a trapezoid formula. In example 2, it asks us to find two things. It says find the median and the area of the trapezoid. So recall the median formula is equal to 1/2 the two bases added together, base 1 plus base 2. And we have enough information to calculate that out. So 1/2 base 1 is 12 plus base 2 is 18. So that's equal to 1/2 of 30, which gives us 15 units as the length of the median. Now for the trapezoid, finding the area of the trapezoid, since we have already calculated out the length of the median, we can use that second formula, which is median times the height. We know the length of the median is 15, but now we must find the height. That's not given. So if I were to draw in one of the heights of this trapezoid, I now have a 30, 60, 90 right triangle here, and a rectangle off to the left. Since opposite sides of a rectangle are congruent, this piece would be 12, and since the whole thing was 18, if I were to subtract those two, I know that this part of the base, leftover piece, is 6. That 6 is across from the 60-degree angle, so I'm going to recall back from chapter 9, the side across from the 60 is equal to x square root 3. And now I'm going to solve this for x, so I'm going to divide both sides by the square root of 3. I can't leave my answer like this, so I need to multiply the top and the bottom by the square root that I want to get rid of, because we're not allowed to have a square root in the bottom. So I get 6 square root 3 over the square root of 9. I know the square root of 9 is the same thing as just 3. And then I can reduce 6 divided by 3 is 2 square root 3. So I know now that x is equal to 2 square root 3. X is the side across from the 30, and that's what we were looking for, the height of our trapezoid. So now I'm going to multiply 15 by 2 square root 3 to get my final answer, which is 30 square root 3 units squared as the area of this trapezoid. Now if we take a look at example 3, it says to find the area of the trapezoid with a median of 12 and a height of 4. Now again, some people get stuck on this problem because they forget that another way to calculate the area of a trapezoid is to use the formula, the median times the height. And then the median is 12, the height is 4. Just multiply those two together to get your final answer, which is 48 units squared. For this next example, it would like us to calculate the area of the trapezoid given this information. So to calculate the area of the trapezoid, I'm going to use the height times base 1 plus base 2 divided by 2. Now I have the two bases, but again I need to find the height. And right away, looking at this trapezoid, I noticed that it's an isosceles trapezoid because the two legs are congruent. So if I were to draw in my heights here and here, I know that I would have a rectangle in the middle and then two congruent right triangles on the outside. Recall that in a rectangle, opposite sides are congruent. So this side would have to be 10, and if I do 34 minus 10, I'm left with 24 for these two pieces. Now, since they are congruent, I can take that 24 and divide it by 2 to get 12 and 12 as the two pieces of the base that are missing. Now, this will help me calculate the height because notice I have a triple. This is a 3, 4, 5 triple. So I have 4 times 3, 5 times 3. So to calculate the height, that's 3 times 3. Now I'm just going to substitute all of my numbers into my equation. So the height is 9 times base 1 is 10 plus base 2 is 34. And then I'm going to divide that entire thing by 2. So I have 9 times 44 divided by 2. And then if I were to solve that, I get 198 units squared is the area of the trapezoid. Now this last example says, find the shorter base of a trapezoid if the trapezoid's area is 52 centimeters squared, its altitude is 8 centimeters, and its longer base is 10. So the first thing I would recommend doing is trying to draw a picture of this, so draw a picture of a trapezoid, so to help us kind of visualize it. And it says the area of the trapezoid is equal to 52. The altitude, that's just another word for the height, is 8. The longer base is 10. And it wants us to calculate out the shorter base. So if we use our area of a trapezoid formula, that would be equal to the height times b1 plus b2 divided by 2. We already know the area is 52, and we're going to set that equal to the height is 8. And then we don't know what base 1 is, but we do know that base 2 is equal to 10 divided by 2. And now we're just going to solve for base 1. So to get rid of that fraction, to get rid of that 2, I'm going to multiply both sides by 2. And I get 104 equals 8 times b1 plus 10. The next thing I'm going to do is I'm going to divide out that 8. And then I get 13 equals base 1 plus 10. If I subtract 10, I'm left with base 1 is equal to 3. And that's my final answer because it was asking me to find the shorter base. So hopefully now you have a better idea of how to apply the area of the trapezoid formula and also the median of a trapezoid. Don't forget that to calculate the area of a trapezoid, there are the two formulas. A lot of times students, like I said, forget that median formula, that you can use the median to help you calculate the area of a trapezoid.